So let's derive the double angle, half angle, and power reduction formulas. So the double angle formulas are, for sine we have 2 sine theta cosine theta, and for cosine we have cosine squared theta minus sine squared theta. And for the half angle formulas, and then the power reduction formulas. Okay, so we will derive the double angle formulas from the angle sum formulas, and then we're actually going to do the power reduction formulas first before we do the half angle formulas, because the half angle formulas will actually come from the power reduction formulas. Okay, in conjunction with the double angle formulas. Okay, so to start with, if we want sine of 2 theta, let's start with the angle sum formula. So we have sine, cosine, cosine, sine, and we'll just make alpha and beta the same. So that means if we just want 2 of theta, that's sine of theta plus theta, which is sine theta cosine theta plus cosine theta sine theta. But we know that those two terms are the same thing, just flipped around, so we can just rewrite this as 2 sine theta cosine theta. So for cosine 2 theta, we're going to use a similar argument. So we'll start with the angle sum formula. So cosine, cosine, sine, 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 and we will just take 2 of the same theta. So cosine theta times another cosine theta minus sine theta times another sine theta, which is cosine squared theta minus sine squared theta. Okay, so for the power reduction formulas, we're actually going to use this cosine double angle formula. So if we want sine squared theta, then we need to extract that from this formula. So we have sine squared in the formula, but we also have cosine squared, and we don't want a power of 2. We're trying to reduce the power. So what we're going to do is use the identity, the Pythagorean identity, which is sine squared plus cosine squared equals 1, and so cosine squared theta is 1 minus sine squared theta. So just rewriting the double angle formula for cosine with our identity. So we have 1 minus 2 sine squared theta, and we want to solve for sine squared theta. So 2 sine squared theta is 1 minus cosine 2 theta, and so sine squared theta is 1 minus cosine 2 theta all over 2. And we will similarly to solve for cosine squared, we'll replace sine squared with 1 minus cosine squared. So for the cosine identity, we have cosine squared minus 1 minus cosine squared, which is 2 cosine squared theta minus 1. And so solving for cosine squared theta, we have 2 cosine squared theta equals 1 plus cosine 2 theta. And so cosine squared theta is 1 plus cosine 2 theta all over 2. So now, if we want the half angle formulas, what we can do is a quick substitution by seeing that with these power reduction formulas, we have the angle 2 theta on the right side and the angle theta on the left side. So theta, that's half the angle 2 theta. So we get the half angle on the left side. So instead of dealing with theta and 2 theta, let's deal with half theta and theta. This formula will still apply if we just replace theta with half theta. So we have sine squared theta over 2 equals 1 minus cosine, and 2 times half theta, that's just theta. And then for cosine, we have, and I'll write it over here so we can do both of them. We have 1 plus cosine theta over 2. So now just solving for sine of theta over 2 here. Well, we know that it's going to be the square root of 1 minus cosine theta over 2, but is it positive or negative, right? Because we're square rooting, so we don't know. Well, we just need to do a quadrant check on sine. So we need to check what quadrant theta over 2 is in, and then we'll know what sine, the value of sine, needs to have. And we'll represent that by the sine SIGN function, or just SGN for short, of the sine of theta over 2. Okay, and then a similar argument for cosine. We'll square root both sides, and we'll do a quadrant check on the sine of cosine of theta over 2. And we have root 1 plus cosine theta over 2. And that's all. Thanks for watching. Let me know what else you'd like to prove. And don't forget to like and subscribe and leave a comment.